Welcome to qnawire.
Okay, so what do we do with this elemental analysis? Right, we were 55.8% carbon, 7.03% hydrogen, and 37.17% oxygen. And this is based on mass. So if we want to find out the mass ratios, if we divide each of these by the smallest percentage, we'll figure out what their ratios are on a mass basis. Right, so let's divide everything by 7.03%. And see what we get. 55.8 divided by 7.03, we get about 8. Okay, and this is going to be about 1. And what about oxygen? I think that'll be about 5. 37.17 divided by 7, yeah, about 5. 5 point, what was it? 5.3. And I suppose this is actually 7.94. Okay. So we know for every gram of hydrogen, there's 7.94 grams of carbon and 5.3 grams of oxygen. Why is that useful? Well, we can convert this into molar quantities or molar ratios if we divide by the atomic mass of each of these elements, right? So we would divide for carbon, we divide by 12. For hydrogen, we divide by 1. And for oxygen, we divide by 16. Okay, so now what do we get? 7.94 divided by 12. That's about 2/3. 2/3. We get 1. And 5.3 divided by 16 is 1/3. Okay, so these are molar ratios. For every single hydrogen, there's 2/3 of a carbon and 1/3 of an oxygen. The final step is to just find a common denominator by which we can multiply everything to get whole number ratios, right? And now, finally, we get 2 carbon for every 3 hydrogen for every 1 oxygen. And from this, we can get the empirical molecular formula, which would be C2H3O, right? So then what we want to do is figure out how much does the empirical formula weigh. Okay, and the reason that we're going to do that is because we know that the actual compound is going to be some multiple of that weight, right? So this is 24 plus 3 plus 16 equals, what is that? 43 AMU. So the empirical formula has a mass of 43 AMU. Now we can look at our mass spectrum data and see what kind of peaks we have. And hey, lo and behold, our parent ion has a mass to charge ratio of 86 m over z, right? Not 83, 86. And if our parent ion weighs 86, that tells me that our parent ion contains 2 empirical units, and that our molecular formula is therefore C4H6O2, right? I just took our empirical formula and doubled everything.